Structures today form a very important part of the solar plant, and when optimization is being done on the plants, a lot of focus is being given to structures on in terms of optimization. People are saying from anywhere to 32 tons per megawatt to 50 tons per megawatt is what the structures are coming as the weight of the structures which the people are proposing. In this webinar today, we are going to cover both ground mount and rooftop systems, the structures which are being used in both ground mount and rooftops. Our presentation is structured in two formats. One is a slightly technical version where we will be just having slides. The other is a photo gallery where we will be showing a lot of photographs to all of you. Now, I have two very learned speakers with me through the to take you through the webinar. Gurpreet Singh Walia and Sathish Kumar. Gurpreet heads the design team at Gensol, which is a leading consulting firm in the country, and Sathish is an engineer from Anna University and has been designing solar structures for the last 2 years. He has in depth information on structure design for canals, for rooftops, for ground mount, including trackers, and also is a very good professional when it comes with to prepare stat reports, which are very essential for designing of structures. So with these two speakers with us, we kick off today's webinar. I will we will keep the mode very in a conversation style. If I have any queries, I would address them to the speakers right at the moment. For all of you who have a query, at the end of the webinar, we will have your questions coming in. There is a chat window which would be there on your webinar screen. On the chat window, you will be able to see you can type in your questions, and then at the end of the webinar, we will answer all of them. So let's start. Welcome Gurpreet, welcome Sathish.
Hi.
I went to one of the plants a few days back and clicked this photograph, and it really scared me off. I hope all of you can see the photograph. This is a seasonal tilt structure at one of the plants, and when the seasonal tilt is going on, you can see what kind of a bending is happening on the structure. I am told that this creates this kind of a bending. If it happens, it creates a lot of micro cracks in the structure, and it is expected that in the next couple of years, with this kind of bending happening twice a year, the modules will get severely affected. Gurpreet, what is your opinion? What do you see in this structure? Do you see the what has gone wrong here?
Essentially, the design part of it, basically, seasonal has recently gained a lot of attention, though it was not used earlier. But the incremental cost converting a fixed into seasonal is not much. So, this is one of the preferred structural solutions today. However, the designs in the race of trimming down the tonnages and cost per megawatt, structures are one of the items which have, really received a lot of attention, that cost cutting is happening on that. So a lot of sections, lighter sections, have been introduced in the market. They're good. They're good for the project, but it's the design part really takes a lot of central thing when we design a solar plant, especially structures. And even in seasonal tilt, there are a couple of things which I'll walk you through. at how we can avoid such instances.
Okay. So we would start off with the ground mount first. Gurpreet, again to you. If you can start off, give us a brief on the basics of setting up structures for ground mount.
Great. So this PPT, while talking of structures, structures can be categorized into three broad categories, whether it is roof and all. So the surface where we are actually putting it, are we putting on the roof or are we putting on the ground? Then which mode of tracking we are taking up. It's a fixed tilt structure. Is it a seasonal tilt or a single axis tracker? Then, in all these combinations, whether we are using mild steel after galvanization or we are using aluminium. So, this is a broad categorization of structures today, right? So, I'll walk you through each of them one by one. Coming on the ground mount, so these are a couple of criterias, a couple of inputs which go into while deciding a ground mount structure. So the first and foremost is what kind of topography your land parcel is enjoying. So if you have a leveled land parcel, right, so you are basically able to use all kind of structures which are possible. Undulated land parcels, our structure table sizes are generally limited because if we don't want to spend much on the land development, so we'll have to use smaller table sizes so that we can go with the contour of the land. Okay, that is one thing. Second is on the soil types. So, four prominent ones we have taken here: the sand, black cotton, rocky, and clay. Black cotton has been one of the biggest problems to structure when it comes to execution because during after immediately after rains this soil becomes a really messy thing for the project. So yeah, this is the categorization where our highest to the lowest we have arranged it. So the clay would be one of the best soils to work upon. The pile sizes which you'll get in a clay soil, they are much better as compared to anything else. Black cotton a little bit more, and sandy to be the highest one to have the highest pile design. Rocky goes in a very different manner. In certain parts of Maharashtra, we have been facing it. So there we go ahead with the rock anchoring. That demands a little more detailed analysis, which would be a little out of scope for this webinar, I suppose. We can take it on a different if anybody has any specific questions. Coming on topography, as I said earlier, that in case you are not having a leveled land parcel, your optimization of structure you won't be able to achieve to that level. So in that case, you might spend up 2 ton per megawatt approximately higher by non-optimization of structures. That was a very quick selection criteria and the major things which go into in a ground mount project. On a rooftop one, so there are two things which generally will be there: uh, RCC slab and industrial sheds. Right. So RCC slab, once you decide which are most of the educational institutions, government buildings, these come under RCC slab. The challenges which a RCC slab or the design criteria or things to look for which go into an RCC slab are first and foremost is that having a waterproofing layer on it, because that really poses a challenge and is one of the most important design criteria that what kind of foundations we'll be going through. Second is some old buildings maybe which were constructed like 15 years back, they might be having brick layers on top of that RCC. And there are a couple of new buildings which are coming with the pre-stressed wires also instead of steel reinforcement. So those even demand more caution while doing the structures work. Coming on, telling you a little bit quickly about the solutions available. In the RCC slab, the solutions available are either we go with the in situ casting of foundations, means we cast the foundation at site as per the design, whichever you get, and on that we mount our structures.
So
Generally,
I'll just
yeah.
sorry, Gurpreet. In situ looks sounds like a very technical word. What is in situ exactly?
In situ means you're casting, you are bringing the material over cement, sand, aggregate, you're bringing to the roof. You are mixing up there and you are in the formwork. Formwork is on your roof and there itself you're casting it. In lieu of that, you can use the pre-casted concrete
So
blocks.
if okay, so you're saying that we get all the aggregate, the structure, everything on the roof, and then we cast it there, and then it's called in situ.
Right.
Okay. And do you think we are in situ is a very popular way of doing rooftop structures nowadays?
It is one of it's pretty popular in India because the infrastructure, kind of structures which we use today, they're not inclined towards the ballasted structures, which we'll explain also how the cost economics work around them. But currently, the structures available in the market, they're more inclined towards in situ casting. However, the ballasted structures are really gaining a pace lately, and
So
we
ballasted
see a shift.
essentially means where the concrete blocks are already casted,
Right.
and then the concrete blocks are being lifted to the roof. Whereas in situ means that you are casting the concrete blocks on the roof itself.
Exactly. That is what it means. The idea of concrete block, I'll tell you whether in situ or it's a precast. Idea is that whatever the wind forces your structure will be facing, you have to hold down the structure, right? And in this case, I'm not assuming that you will be anchoring your structures to the RCC slab
Oh
because
yeah, yeah, hold. Anchoring is a absolutely, it's a very people get very stressed when they think of how should they anchor their structures to the roof. Now, what kind of do we have in terms of anchoring? We understand that either you can anchor through in the ballast you can anchor, or you can do a Hilti solution. If you can throw some light on the Hilti solution. So, how is his Hilti being accepted in the country?
Yeah, so idea of anchoring is the broad idea in a very lucid manner. The thing is that we have to hold down our structures to the roof. They should not fly off, and nor should the modules be. So we can hold it in two ways. One is we physically, connect the structure to a roof. Now, either for that, a drilling in the roof would be required. So people are very skeptical around it. Some people are worried about the waterproofing guarantees about it. So it is, yes, one of the biggest challenges of any guy selling the structures in the market. So for that, we recommend either you can go with a Hilti kind of solution because Hilti is fairly acceptable worldwide solution, and the chemical which Hilti uses, it's a non-porous chemical, and it fills any micro cracks which originate during the drilling. So yeah, Hilti is a fairly good solution for anchoring. However, still, if a client is not happy or doesn't is still skeptical about drilling their roofs, we can design structures where we can put the concrete blocks in such a manner that they really hold it down just with their own weight.
So I'll just go. Just give me a minute. I'll just go to some photographs, and then we can tell people on the. We can tell people on the on what is in situ, and just one second. Yeah. So this, if I
Yeah, so what you're seeing here is a in situ casting. In both the materials, it has been shown in the RCC roof. So these foundations are casted at site, and then these foundations have certain weight as per design, as per wind speeds of those area. While casting these foundations, four anchor bolts, four or two as per design, anchor bolts are casted in the foundation itself. These anchor bolts in no way are connected to the roof, so you are not puncturing the roof in any which way in this case. Yeah, so this saves
so
the drilling part of it.
So you're saying that in a ballast, this is a in situ casting. In an in situ casting, we are using then nuts, bolts which are coming out of the.
Yes, anchor bolts we'll be using, which you can see in this part. In any of the foundation, the base plate comes with a structure at bottom of the structure. That base plate is fastened to this foundation using
And
anchor
Satish,
bolts.
if you can tell me, how do we size these foundations? What are the criteria when we are doing a in situ foundation? What is the criteria that we should take when we are sizing these foundations?
Based on the structure uplift like support reactions of the from the stack, and based on the wind speed we will be getting the uplift capacity. So based on that we can that the concrete has a unit weight of 25 kilonewton per meter cube.
Satish, I will request just be a little more simplistic. We have a lot of audience who might not be as technical as you are, but so very simply, at what speed can you give us a thumb rule that at let's say a wind speed of 150 kilometers per hour, what would be the foundation size, approximate foundation size?
For the wind speeds, we can't derive the foundation size. Based on the supporting span, we can derive the support uplift capacity for that foundations.
So can you give us an example?
For example, if a span of 1 meter or 1.5 meter, due to the module loading and the wind speed, it will be around the 2 kilonewton uplift maximum. For that, we can make an foundation size of 350 by 350 by 350. That will be with an adhesive, with adhesive.
I think you have raised a very good question, very good point on the usage of adhesive. Now, I am hearing from a lot of people that if we use adhesive during our foundation casting, then we can reduce the size of the foundation. Gurpreet, what is your thought on usage of adhesive?
The adhesives have also something new which has come into this sector, and again as a part of optimization. So adhesive, basically, to what Satish was telling, to put it in a very simplistic ways, whenever your module is at an incline, right, so it will be catching winds from the back, so wind will try to push it off. Now that is a value which we derive from the software simulations, that with what force wind is applying on those sections, right? Based on that, we have to design that how much force we have to apply to hold it down.
So the wind, you're saying that there is a module which is mounted,
right,
then there is wind which is coming from the back.
right,
The wind will topple the structure.
right.
So you need to know how big the foundation has to be so that the structure doesn't topple.
Yeah, how big? Because of the weight. So we are basically holding down. It's like a person standing and holding there. But if wind force is more than the weight of the person, he'll himself fly off with the structure.
Okay.
So foundation weight is designed according to that. Now let's say that person is stuck on the roof using a adhesive. So in that case, adhesive provides some strength which is reduced from the concrete material.
But do you think usage of adhesive is safe in your Satish, in your practical experience of using adhesive? Are you feeling that the usage of adhesive is safe?
Yeah, it is up to the 25 years of lifetime. This strength is being tested and approved by the adhesive manufacturers.
Okay, okay, and I'm sure Ezysolare will have adhesive, will start selling adhesives soon on their platform, so all of you can also buy some adhesives from the Ezysolare platform. Great. So now coming to Hilti, do we have some photograph of the?
No.
So on a Hilti roof, basically what we do is that we instead of using the Hilti can go into the roof itself. Now, when the Hilti can go into the roof, that means the Hilti is drilled into the roof.
Right.
So the structure is being anchored there. Now, if what is your people have a lot of skepticism on whether this usage of Hilti provides, does it violate the integrity of the roof in the sense that will rainwater seep in if we do Hilti? What is your expert opinion on that?
So again, it Hilti acts differently on different roofs. In case, so a typical roof slab, if we see on the top floor of any generally all the buildings, it is somewhere from 100 to 125 thick. Now, against the misconception that people have that the Hilti will permeate the roof, Hilti goes only till 80 of it. So you have a good 40 clearance at any time from the Hilti bolt. You won't see Hilti bolts coming out of the roofs. Where it poses a challenge is while doing the drilling, sometimes you might interfere with the steel which has been put in the roof, or in the worst case, in the case of pre-stressed wires. So these are the cables which are laid and then the concrete is done. So you have a risk of the drilling away that wire, and in that case it is compromised. But in other cases where normal slabs are there, no specific RCC has been used, Hilti is a fairly good solution. Hilti comprises of two things. One is the bolt, second is the chemical. The bolt, as I told you, that what is the uplift which is coming on the structure, what is the force, and based on that we get the bolt design. Secondly, the chemical is basically that how much sealing you require to integrate that bolt with the roof. Now, this chemical is a non-porous
will
chemical.
the chemical make the roof non-porous? Will rainwater, if I have drilled a Hilti bolt in my roof and if I apply a chemical, Hilti chemical, will it make completely sealed off?
Yeah, Hilti chemical, the good part is being in a liquid state. So we understand that when somebody drills, even if you drill a wall in the roof, there are a little micro cracks which originate all around. So does that happen in the roofs also. But moment we put the chemical and put the bolt into it, it pushes the chemical into that micro cracks also. So to a large level, this is achieved. However, if somebody is planning to do a big project, they can get it independently tested. Hilti is fairly supportive in their test certificates. And one fact which I'll put forward is that Hilti is the only anchoring solution which is even used underwater.
Which is used underwater.
Yeah.
Okay. In terms of adhesive, Satish, if you can, for our audience, if you can share which is the adhesive that you have generally been using.
Like Dr. Fixit and Post-Rock Nitobond EP. These are mostly used in the solar fields.
Okay. Okay.
Quick Mast also from Dawn Chemicals.
So Quick Mass from Dawn Chemicals, Nitobond, and Dr. Fixit.
Yeah.
Any specific brand name that you would like to give? Any specific technical name?
During design, so every spec sheet which one gets, it mentions the strength which that adhesive will provide while integrating with the foundation. Only thing we have to check, it has to be in line with your design.
Okay, great. So next, I think we have a very important slide, an interesting slide on how much does it cost to do a roof mount structure. And our experts have been kind enough to share their best costing on the roof structures. So Gurpreet, if you can just take us a little bit onto your four options that you have presented: aluminium and ballast, aluminium and Hilti, mild steel plus in situ casting, and mild steel plus Hilti. So these are the various options that you have given to us. What is the cost difference? And if you can also tell us whether if a particular option is more expensive, is it because of the quality issues? Because is it better to go with the more expensive option? So if you can throw some light on for our users on this.
Okay, so in this case, one thing is material selection is very important, and that depends largely on site. So, for example, you are going with a coastal area, right over there, you will prefer using aluminium over MS. So, in that case, even an expensive option might be the only feasible option. So, but we have tried to bring out the best possible prices to you, and these are the working prices in the industry right now. Supply was fairly simple to ascertain. Services is just coming with our experience which we have with different vendors. So aluminium plus ballast structure, I'll tell you that averagely we have considered per kilowatt. The quantities have been ascertained per kilowatt basis, and the prices which you have taken, these are typically for a project size which we get a project size of almost around 70 to 100 kilowatt kind of price, right? So if you see that aluminium plus ballast structure would be a little heavily loaded on the supply part, but so aluminium is coming at, let's say, 185 rupees a kg, but the quantity which is 21. Vis-a-vis, if you compare with the MS structure comes at 70 rupees a kg, which is fairly less, but the quantity is almost more than double, right? So that is where they balance out each other. So in this case, you have to make a conscious choice that which material is suitable. Or let's say you have a slab and the building is a very old building. You really don't want to load it up with the heavy structures because module itself per module will be like 20 kg a module. So in that case, you can go ahead with aluminium.
Okay, okay. So, but in terms of the costing, it's very surprising to see on your chart that aluminium plus ballast is turning out to be the cheapest option. Do you think aluminium plus ballast option will come out as the cheapest option? Generally, people have a conception that aluminium structures are more expensive.
So aluminium structure, if you see on a supply basis, 4.7 it is coming. It is largely because of the weight. Weight reduction is a very good thing in the sections which we get in aluminium. only aluminum is a drought kind of structure. So the extruders which will be in the market, they'll be using dyes. So if you are able to source aluminum at a good price, you will get structures with very good strength. So you can see on the supply part in the aluminum and MS in situ casting, there's not much difference. However, you see on the services part where the difference lies, which is like somewhere around 60 pies. That is the reason is that one thing that it is easy to shift on the roof. Secondly, the aluminium plus ballast we have considered here. So in aluminium plus ballast, if you go in the ballasting, also a lot of form work and other things on the services part are saved from that the INC contractor, right? So you save like 60 pies on the services itself. So if you see as a package, it will come to you at a cheaper price.
Uh, I just got a feedback that the chart on the chart is not being displayed. Just give us a moment. I think the screens got stuck here. Is the screen visible now? We were told that the screen was that the photo that there was a slide which was stuck. Okay, Gurpreet, if you can continue with you were explaining us on the services side of the structures.
Yeah, so as a package, I was telling you that once as a package, you see aluminium plus ballast versus the MS structures and casting at site. As a package, it will cost you pretty less. You save essentially on the services, shifting, unloading, handling, installation, all of that part. On supply side, they balance out each other on the tonnage, on the kgs which are required. So price might be double, but the requirement is half. So that is how aluminium ballast is placed on MS in situ. Now in the Hilti options, we have considered
Yeah,
the same
so
kind of structure.
just 1 second, Gurpreet. I see that because of Hilti, the cost of the structure is going very high. Because when we are doing aluminium and ballast, it is 4.7 rupees a watt. But if you're doing aluminium and Hilti, it is 6.6 rupees a watt. Now, there is almost a 1.9 rupees a watt of increase just because of the Hilti. Does Hilti warrant that we should spend about 1.9 rupees per watt extra on the Hilti?
Any project comes with its own share of intricacies, own share of challenges. So let's say you tell me that Gurpreet, I'm supplying you structures today. You have to install them in like 7 days. I will never ever go with a concrete solution or a ballast solution because I won't be able to get those things in like 7 days. However, Hilti would be available off the stock generally, and the installation time required in Hilti is very, very less as compared to any other things. So in that case, if you're able to achieve your project schedules, it in that case you can have a conscious call that how to if you want to go with Hilti.
Yeah, so I just want to confirm from everybody, are they able to see the table with all the prices? I think it's some issue with the webinar because the table is not getting shown. A lot of we getting the feedback that the table with which we are discussing the prices, that is not being shown. Just give us 1 minute. Let's try to fix this issue. Okay, so let's continue with our discussion. So we are saying essentially that aluminium structure with ballast is costing about 4.7 rupees a watt.
Yeah, the prices are to be noted that they are at a scale of a 100 kilowatt project.
Okay, so
Quantities we have tried to quantify it in per kilowatt so that people are able to construe the same.
okay, and for aluminium and Hilti, the cost is coming to 6.6 rupees a watt supply, and for a mild steel with casting on the roof,
Yeah.
it is 4.9 rupees,
Yeah.
and a mild steel with Hilti is at 6.3 rupees.
Right.
So, the lowest is aluminium with ballast at 4.7, and the highest is aluminium with Hilti at 6.6. But you mentioned very nicely that in case we have a short duration project, then we should go with the Hilti solution, because with Hilti you can complete the project in a very short duration of time. Maybe because Hilti is available ex stock and Hilti can be done very fast, whereas in situ casting will increase the time.
In situ casting, on a very thumb rule basis, I'll tell you, as per Indian standards, you have to do a 7 days of curing before loading any foundation. So that exact 7 days. In that 7 days, you can commission a project and go away from site if you have everything else. If you're going with Hilti.
Okay.
Another small point I'll add in the aluminium plus ballast is, because while designing projects, a lot of designers, a lot of our industry colleagues face a challenge of the capacity. What kind of capacity they are trying to fit on that roof. Now we have to understand that in any ballasted kind of structure, especially the precast ballasted, your height from the roof will be like just 50 to 100 mm. In that case, you'll be having a lot of shadow objects taking away your area. While the elevated structures, if I raise them by let's say 600 using concrete plus MS sections, so in that case, you'll be able to fit in more capacity. So with aluminium plus ballast, you might expect your capacities to fall a little bit. That is also one decision point which you have to take during a project, that what kind of structure you want to go with.
Okay. Next, coming on to fixed tilt now. On the fixed tilt side, what's your fixed tilt ground mount structures? What is your opinion? What is the best in class structure design for fixed tilt now?
Fixed tilt, generally, two type of table sizes are very prevalent in the market, and that is by the virtue of the module size and the inverter configurations available today. If anybody is using 72 cell module of 305, 310, 15, 20 watt peak rating, the typical string size will come out to be 20, right? So in that cases, the idea is to have a single string on one table, or max two strings on one table. People have even gone ahead with the optimization of having four strings on a table, five strings also on a table. But for that, once again, your land, what kind of land you have, what kind of development you want to spend on to, that comes into picture. So yeah, these are the two most prominent, most used sizes, table sizes, which we have told. In this case, if your table size is going more than 4 meter in the height, in that case, we recommend you to going with a double post design, a front and a back. That would help you optimize on steel because moments due to wind force will be reduced. The turning thing, right? So if we support it on the front and back, it is difficult to turn. It's difficult for wind to turn it around. So that is how we are doing it. Now, coming on the sections, what kind of sections are available in the market, which is once again a new thing. Galvalume was Galvalume has been in the picture for almost more than a year now, and Galvalume has been performing very well in fixed tilt. It really helps you optimize structures. We have seen even going to 32 ton a megawatt, 33 ton a megawatt using Galvalume structures. The latest guy in the market is ZAM. ZAM is basically a alloy of zinc, aluminum, and magnesium, which offers a little more corrosive properties, comes at a little more price, but suits it's a more versatile material to be used in different environments. So that is where we stand on fixed tilt. On a thumb rule basis, we are at somewhere around 35 ton, 33 to 35 ton a megawatt, and this is excluding fasteners.
Okay, so you're saying, but Galvalume, can you just share with us? Somebody told me that if you do hot dip galvanization with less than a 2 of sheet, then the sheet gets damaged. Is that true? During galvanization, if we do galvanization on a sheet less than 2 then the sheets are getting bended.
That's very true. The MS comes with a property that at certain point we can heat and deposit zinc on it, but beyond that time, or if we try to achieve the same kind of coating on a sheet section less than 2 it is bound to wobble. So in that case, the section can get deformed to that level that it might be rendered unusable at site. So we recommend to go with the hot dip galvanizations for sections only starting 2 Below that, if you're going, you can go easily with pre-galvanized. And pre-galvanized, we understand that at the shearing points, at the punching points, where zinc is removed, at that point it catches a little bit of rust. Even if you want to be safeguarded against that, you can use a zinc primer or a spray, and that too at the manufacturing, at the stacking, at the dispatch level itself, and not at site. Because handling something at factory is much easier than handling it at site, where it gets spread out all across acres of land.
So you're saying that, just to summarize, you're saying for anything less than 2 of sheets, we should not be using hot dip galvanized because two less than 2 will not be able to.
Yeah, essentially not.
Okay.
In hot dip galvanized, we recommend a coating of 80 microns. It's very difficult to achieve 80 at less than 2 without deforming a section.
Okay, so I think our screen issue got resolved. We're very sorry. We apologize that we were not able to show the screen earlier. I think, but now just to go back a little, this was the chart on the pricing. Of course, all of you will receive a copy of the presentation, so you would be able to see everything. You would be able to get this presentation in your inbox very soon. Now, we're leaving the screen on for about half a minute so that everybody of you who earlier, because of the screen issue, you have not been able to see the screen. If you can just go through the screen and post us any questions that you have on this, on the costing part of structures. So, like we were mentioning earlier, that aluminium plus ballast is turning out to be the cheapest option today for doing structures, rooftop structures. Okay. Now coming to we were discussing fixed tilt, and fixed tilt, as Gurpreet was mentioning, that we have basically two types of structures, which are two types of tables which are running: 4 meters, 20 module structures, and 40 module structures. We also discussed a little on what kind of sheets are best to be done for hot dip. Satish, I want your technical opinion on Galvalume. People are talking of Galvalume. Is Galvalume good? Is Galvalume bad? What is your opinion on Galvalume?
Galvalume it's also the pre-galvalume, like a pre-galvalume material only. But what is it's already the alloy comes with the zinc, so it is like it will be the corrosive resistance already. So this galvanum sections on Indian standard there is no material specifications are available, but on American standards AEZ, like there are two types of galvanums are properties are available, like GR80 and GR50. Like mostly in solar structure they were using GR80 because that sections have 550 MPa of strength.
Okay. So you're saying Galvalume is, can I summarize that Galvalume is safe to use?
Yeah, up to we can use it for the highest strength, 550 MPa we can use it.
Okay. Gurpreet, do you also believe Galvalume is safe to use?
If you go with Galvalume, zero point 0.8, Galvalume is available from zero point 0.8 to 1.2 mm in the market right now. And we recommend using it, we strongly recommend using it in the favor of optimization in the fixed steel structures. And Galvalume, but only can be used in the purlin part of it. In purlins, we can use Galvalume structures. Others, generally sections in
What
the rafter.
about rafters and column? You would not suggest for rafter and columns to Galvalume
So
to be used?
with rafters, we recommend going anything more than somewhere around 1.5, though it is a very design dependent thing. But I guess minimum thicknesses for rafters should not be less than 1.5 mm. And in that case, Galvalume is not available, so you can go with pre-galvanized sections in that case.
Okay, and column post for sure no Galvalume.
Column post, we generally recommend going with the no column post won't be we won't be able to do itself in Galvalume. The
Okay.
entire structure thing will fly off even while installing it. Yeah. So column post 100% either it is pre-galvanized or hot dip. We recommend going with hot dip. And anything column post should not be less than 2.5.
Okay. Now, coming to seasonal tilt is also catching a lot of fancy now. One of the issues that we are facing with seasonal tilt is, and we saw the photograph earlier at the beginning of the presentation, that there is how to do this seasonal tilt. What is the best way of doing seasonal tilt? What is the best design of doing seasonal tilt?
See, once again, what people have tried to do in the market is that a typical fixed steel structures also what we told you previously, people go with one column, one rafter, one bracing design. However, what happens is in this case, people are offsetting it, offsetting the column. The column is not in the center of the rafter; they offset it a little bit, and on the front they will provide a bracing. We'll show you once we run through the photo gallery also. So in that case, what happens in seasonal tilt, your O&M issue is one thing. So people have to tilt it like twice or thrice a year based on your design. While tilting, if you have to tilt all the rafters equally, otherwise you will have a twisting in the structure and whatever. Even it's not just about galvalume. Even if I use a pre-gal structure, I'll be having a twisting if I have a column offsetted. So what in the latest design trends we have started to do and good designers are doing it is that they take a central column on the rafter. So it is centrally supported. So moment you unlock the bracing for tilting it, the the structure's tendency is to come at a 0 degree, or otherwise on a very little effort it can be brought to 0 degree, and the bracings can be realigned to the slotted holes or whatever your tilting mechanism is. So that we strongly recommend going with a centrally supported column rather than an offset column, and a two bracing model and not a one bracing model.
But
And
do you think a two bracing model will increase the tonnage?
100% it increases the tonnage, but we have to see that you are gaining something, but gaining something will come at a cost. It's not just in a fixed steel structure that you will just give just one more hole in the bracing and it can be converted. It's not the case.
So you're saying that typically the conception is that on the same bracing, just give two holes and you can do a seasonal tilt.
No, that as many people have burned their hands using those kind of structures, and eventually they end up thinking of seasonal, basing their financial models on seasonal generations. But due to O&M issues while tilting and all, they end up putting it at a fixed tilt and just forgetting it and accepting it.
Okay, okay. What about trackers? I heard trackers is now a lot of people we meet in the industry are going for trackers now. I think in the last quarter we should have seen at least 400 to 500 megawatt of tracker installations in the country. What is your opinion on trackers, Satish? If you can share some of your opinion on structure design for trackers.
In trackers are there are totally two types of bearing mechanisms are there. One is nylon bearing and other one is a gunmetal bearing. And mostly the nylon in cost wise the nylon bearing is lesser price and as compared to gunmetal bearing. And in
And what is
lifetime,
the benefit of gunmetal over nylon?
and gunmetal will be like more than the 25 years of lifetime without
Yeah.
non-lubricant.
Non-lubricant 25 years lifetime. Wow,
Yes.
that sounds amazing.
Yes.
So and what and nylon life will be how much?
It will be around like will be proper maintenance. It will be around 15 or 20 years.
Okay, so it's not still going to last 25 years. Okay. So do you guys recommend gunmetal bearings everywhere?
It's see, material science has really taken a toll on the structure part. Initially, we used to have 2 to 3 years back. We used to have Teflon coated bearings. They are still being used. They're still functioning well. No reported things of failing on the operational part. Then the again once again even bearings have gone a cost optimization cycle, right? So gunmetal and MS Bright was introduced by one of the vendors, and a special polymers, lubricant, self lubricant polymers, what we precisely tell them, which is even an advanced version of nylon that are being used. So all these new things are able to achieve the 25 years. However, we recommend that whatever bearing material, because people are coming with new things, right? People are coming from abroad, even indigenous vendors are developing it. We recommend seeing at least the test reports, at least the lab test reports, because or any of these material won't be having a demonstration in India at least for more than 2 to 3 years.
Okay. On the leveling part of the ground, I heard that for trackers you need very leveled ground. Uh, eh, I was hearing that it needs to be in plus minus 200 only. So do you think that increases the cost of leveling, and also finding such leveled lands across the country might be a little difficult?
So to understand the leveling issue, we have to see that there are two broad categories of tracker technologies that exist in the market. One is the linked row tracking, what we call as the block size. In a block tracking, you are shifting modules almost of 250 kilowatt, 240 kilowatts in single go. That is basically where a drive shaft and the torque tubes come into picture. So and only single actuator drives this 250 kilowatt of the modules. In that case, we have to have a block level leveling. All those, because it's a mechanically moving component, east to west, north to south, we prefer that within a range of 200 as you mentioned, we should have that whole block leveled. Now that jeopardizes our possibilities, or that pushes us to find level lands. So in relief of that thing, we have recently seen independent road tracking designs introduced by a couple of new vendors and very good vendors across the world. They have come to India now. These people are tracking rows on independent basis. So you can have like 40 modules in a row and a single motor driving only just one row. So then you can have two rows at different levels. Only thing which you will need to worry will be a little bit of row to row shading, which can be again very easily captured in the design part. But on a land selection perspective, we would recommend today going with independent road tracking design. However, if your budget allows you, which I think it doesn't, if it allows you to go with a land development, you can go on a block level development. Every block is not supposed to be in the same level. Just one block, east and west, north and south, of 250 kilowatt is good enough.
Okay, I would like to, I would like to tell our audience that we have one more topic after this. But any questions that you have, please do send to us, because our last topic is on using aluminium structures and what kind of aluminium structures are being used. So before we go into our last topic, if you can send in your questions at the end of there is a chat window which you will have, which where you can post in questions, and at the end we will answer all of them. So Gurpreet, if we can move to the last topic and then we can take up questions.
Right. So basically, so by now, by the virtue of structures being used largely towards the MS and MS, people are generally aware of kind of sections which are available in the market. Aluminium remained a little untouched for a while, but it has recently picked up very well. So we want to tell that as per Indian standards, these are the type of alloys which are available in the Indian markets. Out of these, H30 and N8 are a little difficult to source, I would say, and would come at a premium price. However, they enjoy better properties, right? However, H9 and H20, which is 6061, 6063, these are the materials available in the very easily in the commodity markets. In the even you can track the rates. This is the most available thing in the market right now. So this is the type of alloy. This is how its yield strength and tensile strength and all those things these aluminum grades will achieve. Second is the heat treatment processes. One of the process during aluminum manufacturing. So T1 to T10 it varies. So once again, the most commonly used alloy available in market would be T66063, T66061. So while procuring aluminium structures, make sure your vendors are supplying you that and you can achieve, because T66063, 6061 billets are available.
Okay, just so you're saying that between T1 to T10 as heat treatment, T6063 is the most commonly available alloy.
Yes, that is for the common applications. Other might tend to have a tendency towards special applications, and then their price, is according to that.
Okay, so people need to check on whether what kind of heat treatment has been done. And you're saying that the more commonly available alloys in the market are H20 and H9.
Yeah. So T66063 is the material which we recommend and we use in our own structures. T66063 are the billets which are available on the commodity market for extruders. So they'll be able to give you a good price. And even if you want to check that, you can go to any of the commodity market and even check how aluminium is performing. So these were a couple of pricing issues people face while buying aluminium structure.
But are you seeing on the roof mount? I'm seeing that a lot of people have started to use aluminium. On ground also, do you think we will soon see aluminium being there?
So seeing the market trend, how it is going southwards towards 4 rupees, 434 paisa, I don't think aluminium will be
No,
able
but
to make.
aluminium is coming out to be the cheapest. When on our commercial slide, we had aluminium as the cheapest option.
Yeah, but we have to really see, because I'll tell you it is the cheapest because the tonnages which we have mentioned over there, it is in ground mount the entire thing changes because of the loading scenarios. In ground mount we go in high wind zones unsupported, and the comparison which we did and the design which we did was primarily for rooftop.
Okay, so with this we kind of come to the yeah, with this we come to the end of the speaker part of it. We would now go ahead with the questions. We have, I think, we have a lot of questions which have been asked. So just give me 1 second. I will read out the name and who has asked this question. Yeah, so one of the questions which have been asked is that will you get a copy of this presentation? Yes, of course you are going to get a copy of this presentation. Don't worry at all. So somebody has asked a question on double axis trackers. I am aware, Sathish, that you guys did a double axis 50 kilowatt tracker somewhere. If you can share your experience on the double axis tracker.
The double axis tracker will be both axis it will be rotating, and the tonnage per megawatt will be very higher than as compared to the single axis.
So if you can just tell us, give us some range of what will be the tonnage, and if you can give us some range on what are the difficulties with the dual axis tracker.
Double axis, basically the kind of structural components which will be used in double axis are pretty similar to the single axis tracker. The same kind of material, same kind of torque tubes are there. But instead of, I'll like to share a new design which has been introduced by one of the vendors in the Indian markets, was that instead of, so for example, let's take off, so the double axis and single axis is a good question. It recommends, first we have to understand why you want to put double axis. So let's say you are sitting somewhere in Tamil Nadu, right, at a low latitude. So in that case, double axis won't fetch you very good generation numbers, incremental generation numbers over single axis. In single axis, east to west tracking makes much sense because your tilt angles are less. Now, take a same case if you go towards Delhi or Uttar Pradesh or Punjab, maybe we're at a high lat, where high latitude is there. In that case, in your single axis trackers, you lose the south advantage, right? You lose the south advantage because they'll be tracking to east to west. So whatever generation gain you get over that, you're losing something on south. So on the same structure, you create a little bit of tilt towards south, though it doesn't track, but it stays at, let's say,
So
5-degree tilt.
We hear it is called a polar structure.
Yeah, it's kind of a hybrid between dual axis and
It's
single.
somebody is naming it 1.5 axis structure.
Yeah, maybe, yeah, you can name it as a fancy thing, but that makes much more sense on the cost perspective.
So you're saying on a 1.5 axis structure, especially if we are on higher latitudes, we give the structure a certain tilt, maybe 10 degrees, and then rotate it east to west.
Yes, but in that case, it is.
Have you had any practical example doing that?
Yeah, in Punjab, we have a running project we can even share for our attendees. We can find out the generation numbers, how it has been performing, the incremental generation which is giving. What the vendors were claiming, it is giving at least 1.5% more.
So your recommendation will be to do a polar 1.5 axis structure.
Yes, 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 and that too in the we have to go with the lat long because we don't want, we should invest very carefully on the structure and we have to compare returns with it. So with double axis, yes, where you would, you can go with double axis, but I don't think it will be a good worth for the money for the prices which we are getting today.
Okay, good. So next question we have is from Ketan Jasani, who's my very close friend also. He says, any extra measures to be taken for plants near the sea?
Yeah, so one thing we are doing, one of the projects very close to sea, it would be like more than a megawatt project. We are preferring using aluminium structures there. And in case you don't want to go with aluminium, you can go with recently introduced structures like ZAM, which is zinc, aluminium, and magnesium. Which
But one thing is on the corrosion part of it. I think the other thing is also on the wind speed near the sea.
Wind speed is 100% as per design. So whatever sections will come, how do you anchor them, how do you ballast them, that will be captured in detailed design, and your design consultant should be able to capture that, which I'm sure any good design guy would do it. But on the material perspective, you go with anti-corrosive ones. There are even paints coming in the market, which are even after galvanization, they prefer putting up paints of zinc primer. So you can even explore that option.
Okay, so one more question that we have is, what is the specification of Hilti bolts?
Specification for Hilti boards, generally we are for rooftop, we are using 150 10 dia, and M10 we are using for rooftops, and the depth is generally taken as 150 because 80 will go embedded in the roof and the remaining one will be outside.
So you're saying
Okay. And in and the one a little tricky part with Hilti is that Hilti loves doing design themselves. So whenever you have a requirement, I can share the number of I can share number with your Hilti guy's number with you. They will give you very good design report, and because their integration with their chemical is very important. So what kind of chemical we are choosing and what kind of bolt we are choosing, their compatibility is also one thing. So in that regard, they go on very case to case basis.
so on the there's another question which is on the tracker side, uh, between nylon coating and PVC. does it get impacted due to coastal areas or in extreme harsh environments like Rajasthan? Have you seen that these polymer based coatings will function?
See, some time back, I was even seeing FRP structures coming into picture. FRP, as we everybody are aware, they're used in the where steel doesn't sustain. They use FRP structures. So yes, people are doing those kind of things also, and this can be explored. But once again, we don't have any demonstrable projects which have been done with these kind of structures. And however, the kind of polymer again, we'll have to go with the test that if that testing is sufficing to that site's requirement, we can go in that. But we don't have any costing or any data vintage to prove that these kind of structures are doing good over there.
One of the important things that we kind of missed on our webinar is on the fasteners. My personal question to Gurpreet and Satish, especially to you, is what kind of fasteners are you recommending?
For mostly aluminum structures, SS fasteners are better. And then for near coastal zones also SS fasteners. And now in market it is dicore fasteners also playing a major better role in corrosion resistance, and hot dip galvanized balls for the normal zone location.
So you're saying SS fasteners. So any and what is this on the Dico fasteners? If you can explain to our audience, what is this Dico fasteners?
It's a normal fastener, hot dip galvanized fasteners only. It is taken into the another dicore mechanical coating on the fasteners.
Yeah, only one or two people are supplying them in the Indian markets, and they have demonstrated that it is resistant to the chemical impacts as good as SS. However, in SS, we have to understand that at some point we have even seen SS fasteners cracking at site. So we have to be really cautious because dico is just a coating, right? It's not the material. So we have to be very sure on the material specifications during the connection design in our structures and what kind of design material we are using. Over that, if you can have a dico coating, it would serve the purpose of SS. However, we don't recommend it using for the modules because module guys explicitly tell to use SS fasteners for module mounting.
I think one of the questions that also was there on rooftop structures for industrial sheds.
Okay, so coming on the industrial sheds, once again, I would like to tell you that the considerations which we take in is the kind of profile which we are taking on the industrial shed. Means clip lock is there, trapezoidal is there, and corrugated is there. So every kind of profile here enjoys that kind of solution. It is readily available in the market. Very important thing which we have to see is that are we having the truss work which is available below the roof? It should be sustaining your loads.
Yeah, so you can all see installation of structures on the metal roofs. We can see these are aluminium rails which are being used to mount the structures. So you can these are small sized aluminium rails on which the panels are being placed. Gurpreet, anything that you have to say about this structure?
See, this structure, the rail solution which you are seeing, it is very typical to a trapezoidal roof, which is one of the most common ones available in the market. Now, a lot of people ask that if we are having an asbestos roof, so should we go for a roof change or a corrugated profile where clamps are expensive? So we have there's another proposed solution for that. So this is a kind of thing where we are in this case we are not loading the sheet. So one thing you will observe in this slide is that the sheet is taking the load and not we are not loading the modules directly on the truss work which is below this roof. However, in this kind of design, this bolt will come out of the roof and it will be loaded on the truss work, actual truss work. So in this case, the sheet strength doesn't come into picture much. So this is a kind of structure which can be used for asbestos also.
Okay, good. So these are some of the photographs of gunmetal bearing single axis trackers, nylon bearing single axis trackers. This is the photograph, I think, what you were talking of, the seasonal tilt with centrally offsetted.
Yeah, so the right one which you're seeing is a centrally offset column post. Even the below one is a centrally column offset. The left side, the left one, the top left one is the centrally supported one where you can see that the rigidity, the alignment throughout the structure you are seeing is very good and it remains intact even after module mounting. So we recommend going with the top left kind of things.
Okay, one question was there on the tracking system, how many columns and how many rows can be taken?
Rows and columns are very, very typical to the tracker supplier which you are taking because it depends on the actuator which they'll be using, what kind of load it can take. A typical block, a typical tracker will take 20 modules on each side of the drive shaft, which means 40 modules in a row, and 12 to 15 such rows it will be easily able to take.
Okay. Maybe one of the last questions that we can have is that what is the reliability of single axis tracker?
People are very apprehensive of that single access tracker will bring in a lot of O&M issues and other things. However, that's not the case. The components which are used, see, steel is steel. You use in fixed, you use in seasonal, you use in single access. You
But what
have to
about the rotation? What about the
Yeah,
rotation?
so rotation is where you have to be you have to be very cautious in choosing which kind of bearing you are using. So which is one of the components which might demand which has O&M as a variable. So you have to be cautious on the bearing selection. Then you have to be cautious on the actuators which you're using. So some people are using linear actuators which are DC motor driven or AC motor driven. Those are very common things. A couple of suppliers in India are even using hydraulic ones. These hydraulics are the same which are used in excavation machinery or JCB and all. So you and those components are very easily available. There is nothing, not even a single component in a tracker system which is a very specific and you can't get in the market.
Okay, great. So I think what I would like to say is that Gurpreet, Satish, thanks a lot. Thanks for your time on a Sunday morning. Thanks to all our audience for sparing your time on a Sunday morning and attending to the webinar. I hope it has been useful. Of course, a little about Easy Solar. Easy Solar is trying to do a good job in the solar market by getting in a lot of vendors on our platform and helping people buy a lot of material, including structures from the platform. Mohit Agarwal, he's our chief sales guy. I'm sure you keep getting a lot of emails from him. Just write into Mohit Agarwal for any of your requirements, and Mohit will be very happy to help you. Do use Easy Solar also for creating PVSys reports and which we call as solar energy assessment reports and layouts for electrical design, and use Solar Cart for purchasing material for purchasing your solar requirements through Easy Solar. Thanks a lot, everybody, and look forward to meeting you very soon. Thank you.